everyone. Welcome to the show today. My name is Chris Knuth. I'm going to be your walkthrough for the AP Calculus AB exam. If you're here, I can only assume that you naturally are 100% in love with this awesome subject, which I'm pretty sure no one in their right mind says that, unless you're this crazy guy. I actually do love math. I can't get enough of it. I like that it's exact. There's always a solution, no matter what. We just have to remember how to react accordingly when it comes down to the test. I do have a very jam-packed hour in store for us today. We are going to be focusing on limits and continuity. Essentially, with schools being shut down toward this part, this is when you would normally be prepping for all your AP exams coming on up. What that means is you haven't been in school. You unfortunately haven't really had a lot of time to review in your actual classroom from your instructors. So we are going to start at the beginning and get you one step closer to the inevitability of this test. I hope everyone's ready to go. First, before I get too far into it, please allow me to introduce myself. I'm today's expert. My name is Chris Knuth. I am a star tutor with the Princeton Review. I started with the Princeton Review way back in 2004. You heard me correctly. I'm preparing to celebrate my 16-year anniversary with this company. I studied math. I cannot get enough of it. Again, thankfully, math was just kind of the one subject that just clicked with me. I didn't have a lot of time to study, so I had to go with my strengths. And then after that, I actually realized how much I love to eat. So I became a classically trained French chef with special focus in advanced baking and pastries and hospitality management, all aspects. As you can see from my resume, I am certified in every single test that we offer, except for the MCAT exam. I'm absolutely anti-tests that take a ridiculous long time to complete. I'm also what's called a master trainer for the Princeton Review, which means I'm responsible for training new teachers. I essentially teach the teachers how to teach you all, the students. I'm also a content development author. I do editing, reviewing, and I've authored 3 calculus publications through my company here. In my spare time, sadly, you will find me with my nose stuck in a math textbook, usually calculus, making sure I'm staying up on my skills. I'm also actually trying to learn how to draw. I've never drawn in my life, and it's forcing me to use like a different side of my brain. And I'm trying to focus on like hyperrealisms, like that eye that you see there. It took about 9.5 hours, not in one sitting. Like I take a break after every hour, and then the water drop. Basically mastered the shading. I just had to use like 2.5 weeks, just to get the blending and shading all in there. Video games, and of course, MCU movies. Please do feel free to check out my Star Tutor profile at PrincetonReview.com. Definitely you can find out a little bit more about myself. So here it is. Anyone excited? Anyone like wigged out? It's like a completely uncharted territory here, quite honestly. Definitely when this all stemmed from, College Board supposedly polled a nation of students, and everyone said they still wanted to take the exam this year, which absolutely makes perfect sense. Think of all the hard work that you've done. What I can only assume is billions of practice questions to learn this subject. And now everything's being trimmed down to just simply 2 free response questions. It's insanity. Essentially, what that's going to mean is that it's going to be a big blend of all these topics. You should see that I have units 1 through 7 are included on your AP exam. Unit 8 is not. So anyone who sincerely despises area, volume, cylindrical shells, enjoy the reprieve. Here we do have, or I have the big 7 highlighted in yellow for you to take a look at. Today, we are going to be focusing on Unit 1, essentially. I'm going to be lumping a bunch of differentiation ones together in the session 2. And the third session, we're going to take a look at applications of the derivatives. We have to focus on limits and continuity today because, as I'm sure you're well aware, it's what calculus is founded on, the idea of infinite possibilities. Geometry traps everything within straight lines, a square, a rectangle, a triangle. Calculus talks about, well, what happens when we have curves in the world? That's why it is the best math. It basically provides solutions for everything that geometry doesn't immediately provide. Please do feel free to check out the AP coronavirus updates.collegeboard.org. This is going to be your ultimate tool for finding out everything that is going on with your AP exams. And again, I'm not going to like talk through these pages because you have perfect access to all of this. It's going to be at that College Board website. Here, it's just going to talk to you about like test dates, time, the timing for the exams. Again, like 25 minutes for the first question, 15 for the second. Between those, you're going to have 5 minutes to upload the first question, 5 minutes to upload the second question. And again, you're going to see condensed time frame. And so that's what like College Board has right away on there, what to expect with the breakdown, the free response questions. Your teacher may have mentioned throughout the year when you are at, should we try to learn Unit 8 or leave from BC? Honestly, it can't hurt to know it, even though it's not going to show up here. If you're moving forward, you do have to embrace it. So absolutely. One of the things I want to put up here real quick, if you just want to know the bare minimum that's required to get the job done on this test, this is absolutely your best resource. I'm not biased. Don't get me wrong. I work for Princeton Review. I'm well aware of this. I'm just saying we're kind of a test prep company that everybody else waits for. They're not going to roll out stuff until we roll without stuff. We are that good. I promise you that. This will probably be your best resource no matter what. It shows everything. It's got 6 tests for AB. And then we definitely have the same thing as well for BC. Definitely check it out. And make sure it's the 2020, the most recent edition, my friends. So what we're going to be taking a look now, we have to make sure that we know exactly what's coming ahead of us. This may sound like a breath of fresh air for a lot of you. Is everyone familiar or have heard the expression, the open book, open note exams? It's essentially going to be an amazing resource for you because you're going to get to put everything that you feel you need on paper and have it on display. Full disclosure though, think about if you've ever had like annoying teachers giving you an open book exam. Don't get me wrong, like they're the teachers that when they say open book, you are happier than ever. There are also teachers that when they say open book, they actually make you go and dig through all these, like it's the worst test you're ever going to take. I'm not saying that this is going to be either one of those exact extremes. I'm just saying proceed with caution. Don't just assume that because you're creating like this open note format structure that you're not going to have to know what you're doing. No, that's exactly incorrect. It could not be wronger. Here, you have to make sure that you are looking at the generalities of everything, but then you have to be able to apply it in the specific questions that they are requiring of you. Again, you want to make sure that you have some kind of structure to it, though, first of all. And again, this is all available on the College Board website. I'm not going to waste too much time here. Just put some order to it. Like I know my OCD kicks in hardcore when stuff like this happens. So I know I would do one session with my limit properties, all my big boxes of information. The second section would be just the differentiation, both including the limit definition and all those awesome shortcuts. Which isn't it kind of a slap to the face when your teacher makes you do all the ridiculous limit definitions? And then you get to like section 3.3, and it's just the power rule is the best thing you've ever encountered in your entire life. Yeah, ultimately, calculus is kind of built to undo itself in the long run. You spend a half of the year moving in one direction, taking derivatives, and then you spend the remainder of your entire calculus career figuring out how to undo that. Built to undo itself, ultimately. And so on collegeboard.org, don't forget to check out all the information. Now, resist the urge of going online, quite honestly. Remember, it is very opinionated online. So what may work for some may not work for everyone. And just because you have like an example there that you found specifically doesn't mean that you can just directly copy it onto. No. College Board is very aware of everything that's available to students, especially in this situation. I figure I'm going to open up right away with absolutely what should be fluent for you right now. The unit circle. I always find there's such a dramatic difference in how you learn it based on teachers. Some teachers just give you a blank piece of paper, make you fill everything in, and just straight up memorize it and keep filling it out and keep filling it out. Other teachers actually walk you through and show you like how to arrive at them. So you're not exactly forcing memorization. You're just remembering, you're internalizing it. I do want to show you probably the most amazing shortcut I've ever encountered. I actually learned this when I was running an SAT training down in Puerto Rico a couple of years back. Basically, I'm going to show you how to just arrive at every value you could ever need. So up top, I'm going to put all my degree measures. We know the big 5 in calculus: 0, 30, 45, 60, and 90. We also know that we have to be fluent with these values and the big 3 trig functions: the sine, the cosine, and the tangent. First of all, I'm going to show you probably the friendliest way just to arrive at every value you could ever need. And you may very well have had your teacher show you this. You really only have to focus on the top row, the sign row. If anything, remember the following. Everything is a fraction divided by 2. Everything is, I promise you. Now, everything in the numerator is a square root. Again, I promise you this is the case. To remember your appropriate values, just count up from 0. Huh. Sine of 0 is 0. Sine of 30 is 1/2. Root 2 over 2, root 3 over 2, root 4 over 2, or 2 over 2, which is just 1. That's the only row you have to memorize, technically. Because now you're going to go with the cosine. You may already be aware of this, quite honestly. I just like to remind everyone up here so you don't stress on your big 5. The cosine row built it the exact same way. Everything's going to have a radical and cut in half, a radical and cut in half. The only difference, you may already know, we're not going to go the same order that we did for the sine. We have to go backwards for cosine. And so 0, 1, 2, 3, 4. Like I said, as long as you remember that very first row, you're going to be able to backtrack your way through the cosine, and you already are well aware, I'm sure, the way to arrive at tangent when you have a sine and a cosine, divide them. That's it. 0 divided by anything, we're clocking in at 0 for the tangent. 1/2 divided by the radical 3 over 2. We're dividing by a fraction. If you notice, keep it, change it, flip it. I still, honestly, to this day, have absolutely zero idea what that even means. I just know multiply by the reciprocal and rationalize. You're going to have a radical down south, so it will get the more appropriate form of that. We know tangent of 45 degrees is going to be just 1 because sine and cosine are perfectly equal to each other there. Anything divided by itself, hallelujah. The 60 degrees, as you may already notice, is going to be the reciprocal of what we just did in the 30 degree. So it'll end up with just a radical 3. And remember, if you've ever graphed the tangent, there are a lot of vertical asymptotes when it comes down to it. Because we're dividing by 0. Remember, cosine of 90 is 0 degrees. Therefore, it's undefined at those odd intervals of pi over 2. Now, this as well could easily seem like a lot of work. I'm actually going to show you how to do that just by looking at your hand. So hold your hand out in front of you with the palm facing you. Starting from your pinky, count up in the degrees. 0, the ring finger will be 30, 45 for the middle finger, 60 for the index, 90 for your thumb. So I'm going to keep this table on display because I want to show you how you get what we need to do. If anything, let's just start simple. The 45 degrees. Fold down your middle finger. The bottom fingers, those are going to represent your sine. The top fingers are going to be your cosine. Notice how you have 2 fingers below the middle finger, root 2 over 2. Remember, the only thing that's different here is the number in the numerator. However many fingers you have when you fold your finger, that's going to be what goes there. So the cosine of 45, again, we have 2 fingers above our middle finger folded down. That's our cosine of 45, root 2 over 2. Check it out with the 30 degrees. Fold down your middle finger, or your ring finger. Wow. There's only 1 finger now below, which sine of 30 is 1/2. Square root of 1 over 2. The cosine we know is going to be the root 3 over 2. And we've got 1, 2. Oh, I can't make it up. It's like voodoo. But you got the root 3 over 2. Some people have seen that. I know not everybody has seen it. I just hope it helps, honestly. Kind of never have to even think about a unit circle at all. It's definitely a game changer. I'm always about whatever is friendliest. One thing I can say with College Board, they don't know a whole lot of different ways to test you on the exact same stuff. If you've taken an SAT or an ACT, you know exactly what I'm talking about with standardized tests. They're all identically same. Here, we just have to take a look at some core concepts that are going to be addressed on your AP Calc AP exam. Let's move on with the show. The thing that started it all, wow, Sir Isaac Newton. outstanding individual for coming up with this amazing math. Basically, we're looking at infinite possibilities here. Limits, we know they always arrive when we are trying to get as close as possible to a value that we can't exactly just evaluate at. Don't get me wrong, quite a few of the limits, you're absolutely just able to plug in the numbers. But like if you're going to infinity, you can't plug in infinity. That's unable to be calculated. Let's just bring it down to the beginning real quick. We know we have to go from the left and the right. How do I know if a limit exists? What must be true about the left and right limits that we are getting? Who knows? Sound off to your moderator. We know a limit exists when. And whenever you have like a good number of responses, Shadna, definitely let me know. So we know like here, I'm only looking at the left-hand limit now. If anything, it's trying to tell me to approach 2. If I get closer to 2, well, it seems that I'm going to get very close to 4. I haven't reached it exactly yet, but it looks like that's the case. But am I allowed to just conclude that my limit is 4 here? Have I considered the big picture? See, my moderator's going to town. Awesome. What do they say about the left and right hand limits? How do they have to compare to each other? Mm. Like here, it seems not bad that I would just assume it's going to 4. The only way to verify that, responses may be coming in. If you've gotten a couple or anything, definitely just let me know if they said how they have to compare to each other. If uncertain, oh, I see. They have to, how do I know it's a limit? If I have the left-hand limit, looks like it's going to 4. How do I know? What do I have to verify? They're equal. Beautiful. Perfect. So that's what we have to make sure. Remember, the only way for the limits to exist, the left and the right have to go to the same value. And so here we can confirm by plugging in much smaller, getting closer to, not exactly touching it yet. We can verify, though, we're getting closer to 4 since the limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right. Our limit exists. That's all we have to be prepared for. Ideally, we're just going to be able to plug and play. But when it comes to this test, rarely it goes to the ideal situation, especially like if you ever check out the examples in the beginning of the chapter. Do you ever find like when you go back to look at those, they make perfect sense, but then it seems like the textbook always changes them, or they just instantly seem 5 billion% harder, so to say? Here, we just have to remember how to react accordingly. Don't forget the constant rule when it comes to limits. Notice the k is going to be the constant there. You already know, like from when you learned about derivatives and everything, we just right away take the constant out front. The exact same holds true for the limits. As long as it's not like locked into the function, you can move that out front. It's not going to be any different because that's just a number. So as we see here for an example, when x goes to 5 of 3x squared, just move the constant out front, my friends. Plug in the 5, get the 5 squared, which is 25. Times 3, game, set, match. It's just remembering to do whatever's going to make it easier for you when tackling these. We know there are so many subtle rules. You can absolutely separate the individual limits here. We know that we're looking for when x goes to 5 of x squared and x cubed added together. We just have to go through and see it. We're going to be putting, apologies for that, the addition sign right there, plugging in the 5, we get the 25. Plugging in 5 cubed, we get 125. 25, 125, 150. It works. It's just a matter of remembering that when you can plug it in, that's the best thing ever. Just get the number in there as quickly as you can. Keep track of your work. Don't just make careless mistakes, though. Here again, the multiplication, the product rule for limits. Again, we're going to be evaluating the individual components and then just multiply those individual values you arrived at. Nothing ridiculously crazy here at all. Like I said, these are the best case scenarios when it comes down to it. This can definitely throw a wrench in the plan, potentially. Nothing crazy still. We just have to remember some of the most common things that are going to show up. Again, AP Calculus is a standardized test, which means there are only a finite number of ways they can test you on identical concepts. With that being said, we already talked about the first one. If they do not equal each other, the left and the right, DNE does not exist. Please do be sure, though, to understand the second thing here. If a limit is infinity, it is not the same, it does not exist. It just means no limit because it's unbounded. It's just getting up infinitely larger as you plug in numbers. Here, you should know the most common expressions are when you have just the variable x or even an x squared in the denominator. If we take a look, if we're looking for the zero of the limit when x is getting to zero of k divided by x, I can't plug zero in. Remember, like if you even try to do it in your calculator will actually explode. Totally lied. That's not accurate. Don't believe me. However, if you've never like Googled images for division by zero, check it out. It basically shows worlds imploding. The only person who can divide by zero is Chuck Norris, what I heard. So here, we just see how, if we can verify whether or not the limit will exist. Notice again, though, when we go to zero from the right, we're going to have positive numbers in our denominator, just getting ridiculously large. If I'm approaching zero from the left, though, I'm coming in from the negative realm, which means I'm going to get infinitely smaller or more negative as I get the closer to zero from the left. Therefore, does not exist, DNE. They have conflicting values from right and left. Probably the best one, though, the one that I always secretly hoped would show up no matter what, because this one just clicks. X squared, no matter what you put in, you're always going to get a positive value. Remember, anytime you raise a negative to an even power, game, set, match, positive. It goes away forever. I love when things don't have negative signs, for real. But now, since we plug in anything as zero from the right and zero from the left, it's going to automatically come out positive. We can therefore say there's like no limit because it's infinity. They're both arriving at the same value. They're just not bounded. Well, the other best concept ever. Correct me if I'm wrong, but when you learned about limits and infinity, if I'm not mistaken, it should be like chapter 2, section 5. Here, we have to figure out what's going on. Your teacher showed you a very lengthy way to safeguard and arrive your answer no matter what. And then ultimately let you kind of either figure out the shortcut or wait a couple days and then told you what the shortcut was. Like here, if I'm going to, for as x approaches infinity, this is increasing without bound. Technically, the approach here, I just have to grab the highest degree out of the entire expression, numerator or denominator, and then divide every term by that highest degree. Like here, the highest degree is going to be x to the 7th power. Technically speaking, I would take a 5x to the 7th divided by the x to the 7th minus 3x over x to the 7th. The exam covered more topics from first semester second. Because they're leaving out Unit 8, you're more than likely looking at the earlier stuff. It's definitely going to be a big part of it. There's no definitive way to say what exactly is going to be on. I can only imagine this since there are two questions. I would have to imagine the first one would be stemming from limits differentiation. The second one could be about applications of differentiation. The trigonometric derivatives even, or implicit differentiation, and then of course integration, figuring out for either the can I just use L'Hopital's rule? For this one, well, here, careful though, anytime we're going to the infinity here, don't get wrong, you could totally use L'Hopital's much more frequently than ever. Here, I'm just showing you like what your teacher showed you. I don't expect anyone to be doing this now at this point of the course. Who knows? What's the shortcut for this? What is our limit? Let our moderator know when you have it. If anything, by dividing every term by the highest degree, it's just verifying to you how we can just use our shortcut. Well, keep an eye for what Shauna puts in the chat window. Limits in infinity are actually the very best we can ever hope for. Understood. So that while we're holding on those, I'm just going to finish showing the work that like your teachers are required to show you when you're first encountering this. If anything, to help identify, focus on what's left. Okay, so that's what I'm talking about here. When you have to find a limited infinity, notice how the numerator has the highest degree power. Basically, this first term, I'm only going to have a 5. The next one, I'm going to have, well, no number up top. So that'll be an x to the 6th there. Notice how everything else is still going to have an issue. What happens here when the highest power of x in any rational expression is up top? Your numerator is never going to be smaller. It has to be the biggest one, and it's increasing without bound. Shortcut, if your numerator up top has the highest degree, your answer is infinity. It increases without bound because you still have a term up top. Be super careful here. The 5 is looking like that. Yeah, no. All we're doing here is to show how to identify what to use these. This was the first thing that you got introduced to. There are 2 other things when limits go to infinity. First things first was the power of x being the highest degree up top. Here, we switch it up. Notice we've put the x to the 7th term in the bottom. No matter what's always going to be greater, your numerator or your denominator here? Since I have the highest degree in the denominator, what's going to always be the larger value location, up top or down below? Technically, we could divide each term yet again by the highest degree. If anything, if you just need a quick recap of it, check out the box. You're always going to have a larger value down south, which means you're going to take something 0 up top divided by anything that's getting crazy big because you have an x to the 7th power down south. 0 divided by anything, just 0. This is going to be when you have your denominator with the highest exponent or highest degree and you're going to infinity. When everyone was saying 5 for the limit on that first one we did, you remember the shortcut. We just have to verify when and only when that applies. Oh, here it is. My leading coefficient up top is the 5. My leading coefficient on bottom is 16. My answer is 5 over 16. You know why? Because you have an x to the 7th. Your degrees equal each other up top and down below. That's why these 3 are the shortcut. Again, your teacher had to show like dividing everything by the highest degree variable term throughout the entire expression just so you got comfortable with the mechanics of it. Now, all you have to do is just remember how to react appropriately. When you have limits at infinity, it simply determines where the degrees are located for how your answer is going to be. When up top has the highest degree, infinity. When they're equal, leading coefficients, 5 over 16 here. And when the denominator has the highest degree, 0. Outstanding. So when it comes to limits, don't go too crazy with them. Trust me. It's never going to be anything impossible. There's got to be a way to tackle it, no matter what. So go ahead and take a look at the third one. Feel free to work it out. If you feel you do identify a value, let Shadna know and she'll submit it to me. First one is limit as x approaches 3, that rational expression. Ideally, we would just plug it in. The fourth one, though, limit goes to infinity. Uh-oh. Can't determine that by plugging it in. You have to know the shortcut. Remember, with limits, they're Basically, like a slight annoyance based on functions that you're very well versed in. Got no limit for number 4? That I have the highest degree up top. If the numerator has the highest degree and I'm approaching infinity, we're looking at infinity or no limits. But now the third one. I can't just plug in the 3 because of the denominator. Again, I'm going to hit the no number down south. But now up top, I have a quadratic. Down below, I've got an x minus 3. Oh, I'm going to try to see if I can rewrite and simplify a little bit. Set up your parentheses. 4 is infinity. Beautiful. Absolutely confirmed. Okay, so now for the third one here, we've got x squared minus 2x minus 3. We know up front we're going to have the x's. I need some to multiply to a negative 3 and then some to a 2. The only possible factors of 3 that'll work, the 3 and the 1. Now the trickiest part is the signs. Don't overload yourself or don't feel like you're left alone. If anything, try to see if the rational expression will help you. The beautiful thing about standardized tests, test writers usually like them to work out nicely. My bottom gives me a big clue. I'm going to need to get that x minus 3 term out of there. Therefore, my first factor should be an x minus 3. My second one should be an x plus 1. If anything, when you set the parentheses for factoring, if you're uncertain, always look to the middle term. Since the negative number is the middle term, the negative sign must be attached to the larger number for the factor. Like out of the 3 and the 1, the 3 would be the bigger. The middle term is negative, therefore it has to be x minus 3. Now they go away, and 4 is the answer for this one. Always remember, when you're dealing with limits, anytime you can just simply plug something in, best case scenario, do it. Don't even think twice about it. If you're trying to plug the number in, you're running into a little wall. Here, with the rational expressions especially, definitely look for things to cancel out. Most commonly will happen when you have like a quadratic and linear expressions or that single factor down south. Just be very careful. Don't do stuff in your head. Get it down on paper so that if you do end up hitting the wall, move to a different part of the question, then come back. You may just have to step away from it for just a second or two, just so that we don't get overwhelmed or caught off guard. And so, for your response questions, we have to show work. We just explained the shortcut. Oh, here, you're going to be able to show with limits and infinity. That's the other reason I wanted to show the work. Technically, all you're doing anytime you have the limited infinity, you're dividing by the greatest term or the greatest degree term. And that's why I want to show this step more than anything. Depending on how they're asking you in the question, you could apply this. There's a suggestion for L'Hopital's rule. You can use anything. The question would have to specify if they're requiring you to do it in a very specific way. For the most part, with the free response questions, you can usually get away with just doing what you're most comfortable with, as long as you're justifying by showing some work. With free response questions, though, don't waste time reducing or simplifying, especially when the complex expression got you, that's your answer. A lot of people make careless arithmetic mistakes. Your teacher may have mentioned that throughout the year when prepping for this course. By not simplifying, you're leaving your exactly true statement. You're going to be very much safeguarding yourself to make sure that you don't make any careless arithmetic mistakes. Still recommend you're going to have to show whatever work you need to make sure that you're clearly justifying your position. These may look familiar. If you're anything like when I was taking calculus, I saw stuff like this and my eyes just totally glazed over, honestly. I had just come off a really strong focus of limited infinity that I wanted to see them forever and ever. Second that this stuff would come into play, I just did not prefer these at all, quite honestly. They're never impossible. We're going to do a handful of examples here, at least to show and illustrate what's going on. The first rule is going to be very specific with an x is going to the 0 if you have a sine x over x. It's just going to be the 1. We're going to talk about that if they shortcut shortly. And then for rule number 2, we have the definition for this trig value. The limit is x approaches 0 for the cosine of x minus 1 over x, going to be 0. We have to see, though, how to put it into play. This is going to be the shortcut for the first rule, this first box. Whenever you have it in the form as x is going to 0 for the sine of whatever that coefficient is times x up top, divided by just the x, why is x in radians? Well, because for the most part of the test, you're looking at with the trig functions, you're dealing with the radians. It's usually just the considered acceptable norm with the purpose of the AP test. There are certain things where they should say, like in the directions, that all measures of angles are given in radians unless otherwise stated. Like they do have to put that kind of disclaimer in. And again, on the College Board website for the AP coronavirus update, definitely take a look at the FRQs. They're not entirely all there yet with the FRQs, but the ones that they do have a lot of good insight and information to them. College Board is going to be updating their free response questions, or the frequently asked questions, and providing actual practice questions on their websites, but not until toward the end of the month, if not the beginning of May. They kind of want to leave us all just hanging on the lure and dangling and freaking out mentally. No, we're better than that. We're just going to go and make sure. It's simply just going to be about making sure you're following the rules of it. But like I said, ratings are usually the more accepted norm for these examples or for these rules. If they say differently, then they'll let you know in the question. The shortcuts are just beautiful, though. We have to make sure that we are able to turn anything they give to us into that variety. Because now what I have on your screen right now don't look like anything that was just on your screen. They're never impossible. We just have to focus our thinking. If anything, I know that my limit properties were all dealing with terms of like sine and cosine. I have to start rewriting the first one absolutely right away. Here, I have the limit as x approaches 0 of 4x over the tangent of x. How am I going to rewrite tangent? What is it that it's equal to? And if you're supplying the response, you can totally just write like the first letter of the trig function. When Shauna lets me know in the chat window, I'll absolutely know what you mean. Whatever's easiest for shorthand typing, I'll definitely be able to put it together. Can we use a graphing calculator? Oh, either. Absolutely either of them. You can totally use it. All the acceptable lists of graphing calculators are on College Board's website for sure. Scientific calculator even is totally fine. I would say whichever calculator you've been using for your school year, it's probably going to be the one that you're most comfortable with. Just make sure no matter what, change or replace the batteries for real. So now here, you may have already been thinking or letting Shotna know that the tangent, we talked about a little bit ago when we were filling out that unit circle box. Just take the sine over the cosine. That would be our first step to rewrite it. And then when that happens, well, we're going to have a fraction down below. So let's see what's up. You're going to see right away, step 1, simply to rewrite. The goal always is to look in terms of sines and cosines for the most part. Think back even if you took trig or pre-cal, if you skipped trig and went to pre-cal, that is, when you had to do those verifications of the trigonometric identities, you had to get everything in terms of sine and cosine, usually to make it friendlier. But then that's what I say, we have our division of a fraction down south. And again, we have to multiply by the reciprocal. So we are rewriting this limit to be in the friendliest format for us. Because then we do have our first limit sine identity. It's just a reciprocal. But since sine of x over x is going to have a limit of 1, the reciprocal as well must have 1. And then, since I know the limit as x approaches 0 of cosine of x is 1, wait a minute. How do I even know that's true? Do I have to like know something for that? Or how do I know that that's going to work out to 0? Totally always curious to ask at this point. It says x approaches 0 of the cosine of x. Can I just evaluate it? cosine of 0. That's perfect. Since with the shortcut, notice the 4x for the sine x. Our shortcut was we just have to look at that value, the coefficient for that x term, just 4. So the sine part is 4, the cosine part was 1, product 4 times 1, or just 4. The goal is going to be to make whatever they give to you, whatever shows up, turn it into what you have seen. If you ever feel like you're looking at a question, you feel there's a brand new way that you never thought that you had to solve it out, you need to walk away. You need to step away from that part for a little bit. You're missing something. The beautiful thing about standardized tests, every single question can be done the exact same way. Don't do anything different. This is how you build comfort, familiarity, pattern identification. Don't rock the boat. Just look for what you've done and continue doing it. This one was the trickier one for sure. If anything, and spoiler alert, here, the limit is x goes to 0 of x squared divided by the 1 minus cosine squared. Think back to the Pythagorean identities for trigonometry. Sine squared plus cosine squared is always equal to 1, no matter what it is. Sine squared plus cosine squared equals 1. That's the first thing I have to do to rewrite this. Notice, though, the second that the rewrite is applied, it actually turns into the best solution ever. Again, I honestly cannot justify or see even how College Board would do like anything too crazy. These examples come out of the Princeton Review AP Calc Book 2020. Yeah. I'm just gonna have a little insight to it, showing like how it's gonna be very solid for you. We're just gonna trim it down to the bare minimum of what we have to do. It's just a matter of being super careful, making sure you're getting out of your head more than anything. But when you're rewriting, we're just simply making it look like what we have already seen. The x over the sine x, we've already identified when x goes to 0, it equals 1. 1 times itself, we end up with the 1 as well. And so, thought 1 minus cosine squared of x is super careful. Real quick, I'll put them up here. You have your big 3 Pythagorean identities. The one that you really only have to truly commit to memory, sine squared plus cosine squared equals 1. Be super careful by putting like a negative cosine. Here you're thinking the derivative of cosine. That's absolutely negative sine. We'll review those at our next session. Here, though, we're just doing arithmetic to rewrite it. I had a 1 minus cosine squared in the denominator. I get that because here I just have to subtract the cosine squared over to the other side. Game over. That's the mother lode. That's the one you have to 100% know. If you don't know any of them, like that's the one. Because you can get the other two by simply dealing with the first expression. To get those, take equation 1, divide everything by sine squared. That's it. So equation number 2 is going to turn out to become, well, sine squared divided by itself. Love that. Cosine squared divided by sine squared. Oh, little cotangent action. And then 1 divided by sine squared. Cosecant squared. Again, you only have to memorize that top equation. So then you're just going to divide everything by either a sine squared, as we just did, or the other one now, cosine squared. Again, I know in some textbooks they do show this relationship, or they like leave it as a quick question for like something you have to prove to yourself. Here, this is how I always remembered them. I know I'd never liked memorizing things without like truly understanding them. This was one of those that I just had absolutely no problem memorizing and just running with it. Dividing everything by the cosine squared, well, sine squared over cosine squared. That worked out beautifully. Cosine squared divided by itself. Beautiful. And 1 over cosine squared. secant squared. And you may hear like secant squared, you start to think right away, wait a minute, it is related to tangent. But again, that'll be in the next session. I promise you that. We're definitely going to talk about shortcuts to remember like all your derivatives, which ones have to have the negative signs, which ones better not, how to make sure that you always have the exact value and the exact solutions that you need for them. But I hope this addressed the question. Like I said, I think you're looking at the 1 minus cosine and thinking derivatives. Be super careful, yet still be aggressive. Because now that's honestly limits in a nutshell. That's a whole chapter. It's insanity. What we do have to talk about now is how we identify whenever things are continuous. With that being said, we have to jump into the continuity of it all. And so when it comes to continuity, not everything is perfectly continuous. You have to, beyond a shadow of a doubt, verify the 3 conditions. Always remember, though, this is the order that you're going to check. The second that one of those conditions fails, you're done. Not continuous at all. You just have to remember how to react here. That's what we're going to walk through for the rest of the class. Give you a couple of ways to look at it. First things first, let's talk about the discontinuities. Here, the jump discontinuity, this one you're going to see all it is when it's not the same thing in the graph. They have this like break and one's above the other. That's all it is. Basically what happens, your left-hand limit and your right-hand limit fail to exist because they don't match. That's the jump discontinuity. Different kind of like levels, if anything. We have the point discontinuity. This most commonly happens when you have the values where you have your 3 rows of inequalities maybe, or your 3 different functions, and you have to determine. This is what that is going to be for the most part here. We've got from at A, it'll be a function, but then at the exact value of A, just plugging it in, we have the point discontinuity just above it. And again, they are not equal to each other, therefore not continuous. Here, the essential discontinuity, the most common variety of these, as I'm sure you're already aware, we're totally looking at vertical asymptotes. You have no choice in the matter. And again, to throw a little shout out back to the tangent graph, you know, you have that weird looking x cubed shape, but then it's got the dotted lines and they just continue going on and on forever. You have the essential discontinuities at the odd multiples of pi over 2. Anytime that you have your vertical asymptote, that's this discontinuity. The removable, this is fantastic because actually it's going to be a direct shout out to when we did the limit question with the rational expression and we factored the numerator to cancel with the denominator. That's why they call it removable, because even though you could evaluate the limit at that exact value, you could rewrite it, you could perform a little bit of algebra, reduce the common terms in both top and bottom. And that's why we call it the removable discontinuity, because once you remove that, you were absolutely able to lock in what it was. So let's go big picture here. Here, I have to find out, is the function f of x, separated by those 2 restrictions, continuous at the point x equals 2? So this is going to be a very common way that you were introduced to it. You have the bracket notation, and then you just have to make sure that you're identifying the certain restrictions that we have to. Keep it focused on the big 3. First, can I find a value at x equals 2? And if we can, what is it? Let our amazing moderator know. We just have to verify 3 conditions for continuity. And then our amazing moderator will pass on the knowledge to me. Does f of 2 exist? Can I find it? In my f of x notation, it looks like I have my 2 functions, x plus 1 or 2x minus 1. And I only care about the point 2 right now. So what do I have to put it into? Pun intended. It just happens. At x equals 2, if you're identifying or if you're saying to yourself right now, this bottom function, keep up the outstanding work. That's where x can equal 2. So I just have to verify it totally does. I have a value for it. I can arrive at a solution. Well, what about the second one now? The limit as x approaches 2 of f of x, if that exists. For condition 1, I had to figure out f of 2, and I could do 2 times 2 minus 1 gets me 3. To verify the limit as x goes to 2 for that function provided, don't forget, we have to focus both the right and left-hand limits. Let's break it down. So as x approaches 2, from the left, I'm less than 2 at that point, so I have to go to my top function of x plus 1. Thankfully, I can totally just plug it in and evaluate. 2 plus 1 gets me 3. Now I have to verify from the right. The limit as x approaches 2 from the right. And I do hope everyone can read my handwriting. I know it's got to be frustrating if you can't ever read. If you do need any clarification, please let me know. I definitely want to make sure I'm as crystal clear as I possibly can be. If we're going from 2 from the right, we have to go now to that second function because, well, that's where it's greater than or equal to 2. And I've already determined that I can plug that in directly. Oh, snap. They're perfectly equal to each other. Condition 2, we're good. We're 66.67% of the way there, my rock stars. Condition 3 is probably the friendliest. Are conditions 1 and 2 equal to each other? Game, set, match. Therefore, the answer is yes. So when you're dealing with continuity, you always have to be able to verify and justify your work, showing that all conditions remain true. So, and that's what the next slide is going to see. I just have the work over here to like clean it up a little bit. Again, it's simply about making sure that all 3 qualify. The second that all 3 do qualify and they're verified, your function's continuous, all of it. Let's try another one. Here, looks almost like the same. Can we determine condition 1? Let your moderator know when you know. Does f of 2 exist? Yes or no? Continuity is the best thing ever, isn't it? So I definitely have to focus on the point x equals 2. Can I determine like a value I can just plug and play into? If anything, that's going to draw out the difference between this one and the one that we previously did. Any yeses or no, my outstanding moderator? You're kind of just a quiet chat right now. Understood. So if anything, we are getting to the wire, so I'm just going to short it away. For f of 2, I don't have anywhere that I can plug the 2 into it. That's going to be what they're going to get you on more than anything. Notice how the first one we had the greater than or equal to 2. Here, x equals 2, I can't put it anywhere. Condition 1 fails immediately. Therefore, I'm done. Not continuous at all. Immediately, when just one of them fails, game over. You do not have to continue. Part of the battle with calculus is knowing when to stop the question. Don't forget, like a second for continuity to happen, all three conditions have to go. C1, C2, C3. I'm assuming that was for the first one, not this example two. Want to be super careful, my friends. F of 2 for this second example. Okay, excellent. Good, good. Yeah, the first one was perfectly continuous. There must be a time lag or something. Sorry. But yeah, there's, in this example too, condition 1 does not verify. We cannot identify it. So we have nothing to plug the 2 directly into. So here we go again. It looks like the same exact thing that we've been dealing with. I again have to focus explicitly on the condition of x being equal to 2. Going down the line, I first have to verify that f of 2 exists. Thankfully, I've got the greater than or equal inequality back in play, so I can now go directly to that function. F2 will be 2 times 2 plus 1. Condition 1 is good. Condition 2, does the limit as x approaches 2 of the function f of x exist? Tedious. We're going to go from the right from the left. So limit as x approaches 2 from the left of f of 2. Well, okay. That's no problem. I'm going to put the x in there. If I plug and play into one from the left, I'm just going to get 2 plus 1, which is 3. I'm technically done with the question at this exact moment because it's essentially going to give me like the right hand limit, what I got in condition 1. If anything, just 100% verify limit as x goes to 2 from the right of f of x. I have to use the second expression, which will confirm what we identified in condition 1. We got the value of 5. Yet again, though, this confirms my initial judgment of when to stop the question was absolutely spot on accurate. They conflict with each other. 3 is not equal to 5. Therefore, we shut it down. We're done checking continuity for that problem. It's simply always about, though, going and making sure that you're doing things the exact same way you possibly can. Have to be very careful. Don't do it in your head. Are the different parts of a piecewise function always continuous? That depends on what they're giving to you, because on example 2, no, not even a little bit. Example 3, even, it's not continuous. The second that we make one of the conditions that fail, that's the answer to that question right away. The only one we've encountered so far was example 1. That had all 3 parts verified, which means example 1 was continuous. Example 2, as we had, it didn't even pass condition 1, so we could stop right there. I didn't have any place where x could equal 2. Example 3, the one we just do here, f of 2 I could now calculate because, again, I have the greater than or equal to. Condition 2, though, the limits are not existing, or they're not matching. Therefore, the limit does not exist there. Good question. Here, it completely depends on the individual case. So I might recommend either looking over your notes from the continuity chapter. It's been a hot minute since they're, if I'm not mistaken, you're probably looking at this August, maybe September. It was a real long time ago. Ironically, just long enough to completely look like it's written in ancient Sanskrit now, so to say. We have only 20 seconds left. So, if anything here, this is just going to clean up the work for it. We just have to make sure that wherever they're asking us for the point, that we can at least include the point and determine values for it. Limits of continuity, never impossible, and we already know there's a lot more involved when you get into differential calculus, which is exactly what we're going to be jumping into at the second session. I hope this helped, my friends. None of this is ever possible without any of you. I have to just say, outstanding job today. I know it's lightning quick when we're presenting the material and everything. A little bit at a time goes a very long way, my friends. Just remember, whatever they can throw you, you've already encountered. It's just going to be about looking and playing back and refreshing on your strengths. Keep it real. Don't exhaust yourself after every hour. Take a 5-minute break. Save your sanity. Trust me, it's never worth it. A huge thank you to my outstanding moderator. Thank you all so much again for coming up. Keep an eye out for when the next AP session is. It should be April 20th on a Monday. I will be your awe-inspiring expert trainer for that session as well. Have a wonderful rest of the day, everyone. Stay safe and healthy out there to both you and your family. Have a good day.